Can I proceed with sharing my screen?
Yes.
Okay. Here we are. Can you see the screen?
Yes. Yes, we can.
Great. So this is the story of the impact and the recovery of the meteorite from the asteroid named 2018 LA, found in the CKGR in Botswana. You see that here my name is not alone. We will have toward the end of the presentation Mohutsiwa Gabadirwe from Botswana Geoscience Institute that will touch some of the aspects of this work. As I mentioned before, there were many people involved in the research and in the study of this meteorite, and I'm sorry if I won't be able to mention all of them. So the structure of this presentation, it's more like a timeline of events. So that's how I structure it. So we're going to talk about the asteroid, the fall, the research of the asteroid, so the adventure in the bush, the discovery, and we'll talk about the team that discovered the fragments, and of course, the study of this meteorite and the implications, not just for the study, but for the discovery of the meteorite itself. So we start from the beginning with this asteroid. On the 2nd of June 2018, around 8:14, Dr. Richard Kowalski, which is working at the Catalina Sky Survey, spotted an asteroid that was moving quickly, and he realized the movement of the asteroid. He managed to take these beautiful pictures of this streak. You see the elongated white shape in the middle of these 4 frames. That was the evidence of an object that was moving against the background of the stars. So this object was initially named ZLA F9b2, a rather not fancy name for an asteroid, but that's the procedure. And the Minor Planet Center in USA calculate that this object was actually on a trajectory of possible impact with our planet. So the first protocol is to assess the threat for a potential impact. The scientists at NASA, the Jet Propulsion Laboratory, they soon realized that this object was too small to pose a real threat. The first estimate was for the asteroid to be between 1.6 and 5.2 meters. So not a real threat for us. And the message of the existence of this asteroid start to bounce from one institution to the other. Of course, the community of asteroid observers worldwide was aware of it. And the people at NASA's and the CITES Institute, in particular, Peter Jeniskins, that had a pivotal role in the finding, discovery, and study of this meteorite, but also the scientists of the Finnish Fireball network in Finland, including Thomas Coate, that later joined us in the field. So a number of scientists had their eyes on the problem. So the chain of events was after the observation of this object in the sky on the 2nd of June, there were some calculation of the pre-impact orbit based on the position of these asteroids against the background stars. With respect to an asteroid that is moving, the stars in the background they're not moving. So clearly there were some eyewitness. The news of a bolide explosion with a red flare in the sky of Southern Africa start to spread in the net and in the news, and scientists start to organize parties to retrieve possible fragments of this explosion. So Dr. Jenskin from SETI Institute, together with Oliver Moses of the ORI in Maun on one side, and Dr. Coate from University of Helsinki, with Professor Gibson from Wits University, myself, and my colleague Professor Proyer from BUIST. We all start to try to organize in a very short period of time an expedition to the fallen side. But that's the big problem. We back then we didn't know yet where was the so-called strewn field, so which is the area where most likely you can find fragments of an asteroid that exploded in the air. So the people from the Finnish Fireball Network and also people at NASA were busy making calculation while we were preparing the field work. So I'd like to use these reconstructions of the events that has been provided partially by my colleague Alexander Proyer. So on one side you have Dr. Jeniskins from SETI Institute that once learned about this potential impact on Earth of this asteroid, start working on the calculation, and he actually flew all the way to Botswana, reached Maun, and reached out with Oliver Moses at Okavango Research Institute for assistance in the field. And they start looking for footages and approach the area of the impact, but with no luck because they were missing permits. On the other side, there was us, the Finnish Fireball Network, and Thomas Kohut from University of Helsinki contacted Roger Gibson, and Roger Gibson contacted people in Botswana, myself and Professor Proyer. Unfortunately, I was on my way to Europe the very day I knew about the meteorite, so I missed the first party in the field that met on the 17th of June in Maun. That's when the two groups decided to join in an expedition into the CKGR that was founded by BUIST, BGI, and UB. So we come now to the fall. The early predictions of the fall of this asteroid located the impact in somewhere around Madagascar, until the Atlas telescope in the Hawaii managed to provide more observations, refined the prediction, the calculation, and eventually allowed us to link and associate the impact with the observed asteroid 2018 LA. You see the red bar, it's the observation, the prediction that came after the Atlas telescope provided these results. There was also an important role played by 8 witness report, and part of the job was in fact to collect a witness report, and this is I've taken it from the Fireballs IMO website that collects all the witness reports, all the people that have reported these red flares in the skies of Southern Africa. And they are important because the eyewitness and most of all, the collection of camera footages, like the security camera footages, became crucial for the calibration of the strewn field. once you have videos of security camera that capture a flare in the sky or the explosion of the bolide, you can calculate the direction of the movement of this object. And if you have many of these footages, you can actually calibrate the position of the potential fall using the background stars. And this is just an example. So another, and this job was done by Jenkins and Oliver Moses before we were able to go in the field. Other reports of the explosion came from Peter Brown. This one I took it from his Twitter account, and is actually the detection of infrasound bolide. So this is from one of the many infrasound stations that detected the bolide explosion as another clue of this this potential impact. We also with Roger Gibson from WITS to use the seismic stations that PGI and Witwatersrand University have in Botswana, because if the asteroid is particularly big, you might have some waves at the impact with the ground. But we soon abandoned this option. So thanks to the joint effort of Peter Jenniskins, Oliver Moses, and the colleagues from Finland, we managed to come up with detailed trajectory of the lower trajectory of the asteroid, and build a true field. The colleagues had to calculate the wind direction at the ground and at higher altitude. They had to calibrate all the footages of the video that managed to collect. But on the 17th of June, we had something satisfactory, putting together the information from many institutes and many colleagues, and we were able to start with the first research party. So the first group of people left Maun, entered the CKGR, and start the search. This is what we call the strewn field. This is coming from the Finnish Fireball network. There are several of these, several versions of this, but I want to show you the different colors here are the different mass of the potential meteorites that you find. The explosion, according to this model, likely happen where we have this star, and the fragments of the asteroid spread along this very wide area. We're talking about 45 kilometers long for 2 kilometers width. And rough calculation, it would have taken us 6 months to search the entire strewn field centimeter by centimeter. It is clear then that you must have perseverance, but also a little bit of luck. So while our colleagues were busy calculating the strewn field, we also had to educate ourselves, because it doesn't happen every day that you go out looking for meteorite. Thomas Cohout and Peter Jenniskins are experts of meteorite, but some of us are not. So we had to come up with some meteorite, thanks to Dr. Cohout that shared it with us. What do you do if you find a meteorite? First of all, my personal comment, if you are in the CKGR or anywhere in the bush, whatever you see, it's most likely to be dung, because there are a lot of animals, black droppings, and they match the same color of a meteorite. So, but if you really find one, you have to count down. You have to get the coordinates, take nice pictures, have your phone far away from the meteorite, because the magnets in your phone can actually damage the magnetic properties of the meteorite. Pick it up possibly with aluminum foil, the same one that you use for cooking and that we will see in the next slides, and absolutely avoid touching it with your hands. So luckily we had in the field 3 leaders that knew how to do all this procedure: Professor Breuer from BUIST, Mr. Rabadirwe from BGI, and the meteorite expert from CT, Dr. Jenkins. Because the field work there is very hard. We had a lot of punctures. In my first expedition, we actually had 4 tires left with 3 cars in the field. Here you see Dr. Coat in the top right picture. That is a bit desperate after the numerous punctures. And this place is not a place where you want to get stranded, because there are a lot of wild animals, including lions, as you can see from this picture courtesy of Habadirwe. So I want to show you a couple of videos that give you the impression of how hard it is, this kind of research. Here we were along one of the main tracks, and we had 5 people on each side of the car walking and searching every centimeter of the bush. And we used to walk for 10, 12 kilometers a day through thick grass in this line of 10, 12 people. And we had clearly rangers with the guns to protect us from the wild animal, or protect the wild animal from us. Depends from the point of view. And of course, when you walk in this condition, you have to be careful, because you might fall. Especially if you are busy filming other people. And so you are the one falling and not the asteroid. This area, it's an area that it's of pristine bush. So with the permission of wildlife, of course, we had to open a new route in the bush. The one you see in front of BUIST car is a car from the wildlife department. So the condition under which we worked were particularly harsh and difficult. So this is through the thick grass and then also through the bush. So it doesn't surprise if we had so many punctures. At one point, we had to send the car back to the nearest village to fix all the tires because we had no vehicle left at the camp. Anyway, the group led by Professor Breuer, Mr. Gabadirwe, and Dr. Jenkins found the first piece. In this picture, you see on the first one from the left, is Tembizo Bazupi, technicians from BUIST. The one in the center is Lisedi, the person that actually found it. And you see on the far right, Oliver Moses from ORI. So it's the 23rd of June in the morning, and State Zero Lisedi from BUIST find the first meteorite from the asteroid LA 2018. It's a small, tiny black stone with a shiny crust. And Lisedi was the first one to spot it and call Peter and the others and share with them the good news. After this expedition, there were 3 more expeditions undertaken between June and August, of which I was part and co-leader, but no meteorite was found. The 5th expedition was actually we invited, or the party led by BGI was joined by the Japanese Broadcasting Corporation that was filming a documentary about the finding of this meteorite. So it was a big event. And it's only until October, on the 6th expedition, then 22 more pieces of the meteorite were found. Here I have just few examples, and the one in the picture is Mr. Kabadire from BGI that is pointing to one of the nuke fragment found. And here is Oliver Moses from ORI with another fragment. It's in the aluminium foil, not because they're trying to cook it and make breakfast, but because that's the way it has to be handled to avoid contamination from your hands. And these are other examples of the meteorite, and the ranger from Frei Wildlife is threatening the meteorite with his gun and say, if you run away, I'm gonna shoot you. It was so difficult to find all these pieces. So at the end of the 6th expedition, we had 23 meteorite from the asteroid 2018 LA. So the discovery is just the first part of the very long journey, because now it comes the study, so the science. And you'll see how complex are the studies of this type of material. You have small rocks that are coming from outside our planet. They are of very high value in terms of science, and you cannot dispose of them, cut them, crush them with a light art. Everything has to be planned carefully, and this process of planning was led by BGI and in collaboration with BUIST and other partners. So the first thing to do was to send one sample to the Gran Sasso laboratory in Italy to do some gamma ray spectroscopy for short-lived radionuclides. You will see that in each slide, I put the name between brackets of the scientist that led the task. I'm not going to mention all the names. They are written there because otherwise it will take too long. And I'm not even sure I can pronounce the name properly. So at the Gran Sasso laboratory in Italy, the colleagues, they were studying the gamma ray emission of cosmogenic radionuclides. The reason being that some of these radionuclides, like scandium, beryllium, manganese, they have a very short life. It means that after a few days, they completely decayed. So they give us a good idea of the fall time. And scandium, for instance, have a very short life of 83 days. So after 83 days, there would be no such isotope anymore. So this type of analysis are crucial to link the meteorite you find on the ground with the actual event that has been that occurred. So the asteroid, the explosion. Then Mr. Wantler from BGI went to Helsinki, hosted by Dr. Kohout, and did some X-ray computed tomography, which is another crucial non-destructive analysis. Remember that we want to try to avoid to destroy this very valuable rock. So this type of analysis were crucial to understand the internal texture of the rock before cutting it for the production of the necessary thin sections. And thin sections are small slide of glass where a thin 30 microns, 15 microns thick slice of rock is mounted, and that is needed for petrographic classification. So these preliminary non-destructive analyses were of crucial importance for further planning of the analysis. Finally, thanks to Roger Gibson and his colleague Dr. Ashwell from Witwatersrand University, we had the petrography and the mineralogical characterization of all the meteorites, and this allowed BGI to submit the characterization, the description of the meteorite to the NOMCOM committee that has a database that validates, collects all the meteorite finding in the world. And on March 31st of 2019, so several months after the discovery, the Meteoritical Society approved the application from Botswana Geoscience Institute as official repository for meteorite. And that means that BGI serves as one of the repositories for the representative type specimen of the Botswana meteorite. And it's a very important step in the study of every meteorite. It might sound all about paperwork, but if the Meteoritical Society doesn't recognize this finding of a meteorite, science has no value. So on a small portion of one of the meteorite has been grinded and pulverized, and this was absolutely necessary for reflection spectroscopy and thermal emissivity spectroscopy. These are techniques that allow the production of spectra and that can be compared with other database, and in short, they can give you the type of meteorite you're dealing with and possibly its provenance. This is a picture taken from inside the spectrometer chamber at DLR in Berlin, and the one you see there in the middle is powder from the meteorite. Now, very quickly, other analysis we did, and the centers that took care of it is the thermoluminescence that give you an overall the information about the impact that generated the asteroid. So the maximum temperature and pressure reached at that impact. And it's always important for the reconstruction of the event that and the origin that created the asteroid. Another set of non-destructive analysis carried at University of Helsinki and at the Astromaterial Research and Exploration Science Division of NASA was for the final characterization of the physical properties of the meteorites, for instance, the bulk density. Again, you cannot destroy all the samples, so you need to come up with non-destructive methods to characterize it. Magnetic susceptibility is important. That's why you don't have to go close to the meteorite with your phones and other digital apparatus with magnets. And of course, there was a thorough study of the elemental composition at UC Davis that is always needed for the characterization and comparison of the meteorite with other known meteorites. A very important step in the study of the meteorite was the study of the cosmic ray exposure agent that has been done at the ETH of Zurich in a very sophisticated laboratory with a custom-built mass spectrometer. In this laboratory, our colleagues analyzed all the isotopes of the noble gases, helium to xenon, and this was necessary to estimate the time of formation of the asteroid, because the properties of these gases give you an idea of the time, how long the material of the asteroid has been exposed to the cosmic ray and to the solar wind, so to the radiation. So before it was embedded into a solid mass of rock, and then it has been exposed by an impact, and the asteroid collected this cosmic ray. So it's a very crucial step in the study of the meteorite. Other studies were clearly conducted. Cosmogenic nuclides, these are analysis that provide an estimate of the size of the asteroid. Before these analyses were conducted, all we knew was the first estimate of the size of the asteroid provided by the observation of the object along his trajectory. So these radionuclides have given us a better idea of the size of the asteroid before the impact. Then chronological, so uranium-lead chronology has been carried out. This means that using properties of some isotopes of uranium and lead, geochronologists are able to estimate the age of the minerals inside the meteorite. So this can give you an idea of how old is the parent body of that asteroid, where the asteroid comes from. And finally, the oxygen isotopes that were used to pinpoint the various processes that led to the formation of the asteroid. What is interesting is that the group from the Goddard Space Flight Center, the Helmholtz-Zentrum in München and the University of Toulouse, they also did some very advanced analysis to detect potential organic compounds, and particularly amino acids. You know, amino acids are the building blocks of life, and there are many theories that says that probably these building blocks are coming from outside our planet, and the vector that brought these building blocks on Earth were actually asteroids and meteorites. So this was a very exciting and important piece of the research. So what are the implications for this type of study, this type of research and discovery, and particular not just for us, but for the community at large? Well, for us scientists, this 2000 LA asteroid was a very important event. You must know that out of the almost 60,000 meteorites that are reported in the meteoritical bulletin database, which is the only official database for meteorites, only for 27 we know the source. So only 27 of these meteorites have an address. We know where they're coming from. And the meteorite we found in Botswana is only the second in history of which we know the pre-impact orbit, because thanks to the Catalina survey, we were able to track it a few hours before it reached the atmosphere. So it's event like this that can give us very important clues that can further our knowledge of the solar system. The first of these important meteorite was actually from the asteroid 2008 TC3 that was discovered in northern Sudan in 2008. The asteroid was actually discovered 19 hours before the impact. And the 2008 TC3, the meteorite from the 2008 TC3 asteroid were found by the University of Khartoum and Dr. Jeniskins. This meteorite is now named Al-Mahata Sitta. You can Google it and find many interesting information. A second predicted impact occurred in 2014, but unfortunately, this impact occurred in the middle of the Atlantic Ocean. So for obvious reason, it was impossible to retrieve the meteorite. So the third one was 2010 LA. So the event that occurred in Botswana, and that's what makes this event so important. Now, I don't know if Khabadire is connected. I would like him to take over and tell us something about the heritage aspect of this meteorite. Khabadire, are you around?
Thank you, Dr. Franchi. And let me take this opportunity to thank Astronomical Society of Botswana for inviting us. I'll quickly go through the legal aspect of the meteorites. We thought it would be very important also to highlight that meteorites are actually protected heritage. From the beginning, where Dr. Franchi mentioned the Botswana National Museum. Botswana National Museum actually is the primary custodian of meteorites under the law called Monument and Relic Act of 2011. And we also, on behalf of the government, being an interested party in our mandate, there was an agreement from the beginning with Botswana National Museum that we take the responsibility of coordinating both the curation and the scientific research regarding the finds or the collected meteorites. Therefore, from the aspect of meteorites being a protected heritage, it is also very important to make sure that we protect them from those who just come outside to collect without any permits. And therefore, it is very important for us to emphasize that a meteorite may not be taken from their sites or outside, from Botswana to other countries without a permit issued by Botswana National Museum and Monuments. And also from our learnings from this current 2018 asteroid 2018 LA, we realized that we need to actually, ensure we need to actually, come up with a strategy of response to incidences of meteorite that may fall into Botswana. And therefore, after discussions with the Botswana National Museum and other stakeholders, we believe that it is important that meteorite falls should involve the Botswana Defense Force and Botswana Police Service in safeguarding the sites before, to ensure that no one comes to the sites before, those that are allowed to access the site. And also, we believe it is also important to come up with an emergency funding. I hope I'm still on.
Yeah, yes, you are. Tell me when you want to change
okay,
this.
thank you. Okay. And also, I wish to state that from that point of view, we have also realized that this meteorite fall was not the first of meteorites to be found in Botswana. In the past, there is a record that some meteorites were taken out of Botswana and are now curated in some of the museums around the world or in a certain country. Now, together with the Botswana National Museum, there is an effort to try to, to come up with repatriating the taken meteorites through, next slide, through, thank you, through the application of the United Nations law. And as you see from that diagram, those are the areas where meteorites were collected. These meteorites were called the finds because they have fallen to our country a long time back, many, maybe millions years ago, as opposed to the ones that we witnessed. That's why they are called the falls. And for these meteorites, it is actually, there is a publication that describes how they were found and the types of the meteorites found from these different areas being Uke, Mabe, and Matsitama. That should be Matsitama in northeast. So we have this meteorite housed in one of the museums in Germany, and through the program, the United Nations Heritage Program, we, together with Botswana National Museum, in the effort of repatriating or making, looking at all the laws that will make it possible to bring back our heritage home. Next. Thank you. Next slide. Yes, and then that is actually the Monument Act administered by Botswana National Museum that clearly states that meteorites are protected. Next slide. And then BGI as an interested party also is mandated to respond to geohazard related to extraterrestrial events for risk reduction assessment. So together with its mandate of geoscientific research and geoscience data custodianship. Thank you. Next.
I think we are done. Let me.
Yes, with that, I think we come to the end of the presentation, but it is very important to sensitize the public that, meteorites are very rare, very important, and are protected by the law. And also the handling has to be done in a way that is allowed by the law. Thank you.
Thank you, Mutsiwa.
Thank you.
So just one sentence to conclude and say thank you to everyone. As I said, the discovery, the study involved more than 50 people, 50 scientists around the world. And there is a publication that has been submitted. So the reason why we were unable to share the scientific results, even though they can be very boring, but for some of you might be interesting. The reason why we cannot share it is because there is an embargo on the data before the publication of the paper. And I feel very sorry for this. It doesn't depend from me. And I want to put this one as a final disclaimer so that it's not myself or Mr. Mutsiwa Kabadire that don't want to share the data, but unfortunately it is the system of modern science. With this, I say thank you to all of you, Releboga, and I give it back to Jihan.
Thank you, Dr. Fulvio and Mr. Habadivre. Thank you very much for this very interesting fact-filled presentation. Much appreciated. Are you open for some questions, Dr. Fulvio, Mr. Habadivre?
Yes.
Yes, so there's a short period of time that we have when the participants can ask you questions.
Okay,
it's time for question and answer.
Hello, doctor.
Hello.
Is wrong.
Hello. Can I ask?
Hello.
Yes, go ahead, Raja.
Okay, my name is Raja. I would like to just ask you, you mentioned about amino acids being the building block for the life in Earth, or anywhere for that matter. Did you mention that these meteorites could have brought such chemical into the Earth in the past?
Yes.
Okay, thank you. I'm done.
That was the question?
Yes, please. Yes, please.
Oh, okay. No. Well, the answer is there are theories that says that amino acid could have actually reached our planet billions of years ago through meteorite.
Thank you, doctor.
Hello there. Fulvio, how are you?
Hi, Siamo.
Good to see you.
I don't see you at all.
You can't see me at all. Maybe let me see.
There you are.
To grow an impressive beard. I was trying to grow an impressive beard over the lockdown. I don't think I'll ever reach your height, you know.
Sorry about that.
We actually had a very good expedition, not expedition, but the site visit to Lokalani 2 weeks ago. The BUIST team was there with Professor Tutolo to go see the SKA sites, the potential sites for the AVN and the SKA. So I was hoping to see that. But I have to say, I also remember your emails in 2008 regarding this particular expedition. So I'm sorry the team from UB didn't make it. Seems like we didn't have the resources to come. But having said that, I think there's great potential in using this for STEM, regarding exciting young minds on the value of science, especially some of these specialized areas. So I'll be very, very keen to see if BGI or anybody else is looking at the potential for using some of this data regarding asteroids, regarding all these finds, curate them and also expose them for maybe infusing kids about STEM. I'm saying this because areas like these and planetary science and astronomy, they are very important vis-a-vis Botswana's participation in the upcoming SKA project. So I want to throw this out there, especially for ASB and for experts like yourself, maybe to consider how some of these things could be facilitated. Thank you.
Thank you, Siamo. You know that we are working very hard, even this side, to bring planetary science at large into Botswana tertiary education. So we were actually hoping to use this Meteorite as a leverage for the public opinion, to bring it into the public domain much earlier. But you know how science is sometimes. You know,
yes.
It took 2 years to reach the moment where I'm speaking to all of you, and yet I'm technically not allowed to share. Someone is asking about the composition. Unfortunately, this type of detailed information, they will come soon.
Yes.
What
yes.
I want to say, to follow up to your comment, is that this is an unparalleled opportunity for Botswana to capitalize on its heritage and bring this new topic, let's say, into tertiary education at BUIST at UB, study of planetary science, planetary geology, Earth observation. Yeah, today, what a day, Mars 2020 mission with Perseverance lift off like at 2 p.m. and it was successful. I didn't check lately, so I don't want to know if something wrong, but if something wrong happened, but what a day, yeah? And
yeah, that's exactly.
One day we might be, as Botswana, we might be part of a mission like that. So Jihan, let me put a small advert here. BUIST is part of, in February 2020, BUIST and Botswana became partner of a huge network of planetary science called Europlanet. Despite the name Euro, there are two African partners, which are Mekelle University in Ethiopia and BUIST in Botswana. And that is the first, let me say, even if it sounds arrogant, but let's say the first recognition of the Planetary Science International Society, let's say, the group of scientists that recognize Botswana as a potential partner for this type of studies. So we are working to get Botswana at the forefront of planetary science and space science.
That's very exciting news, Dr. Fulvio. Very exciting. Any more questions? We have 80 participants. That's a very good participation, Dr. Fulvio.
80.
Hello.
Wow.
Hello.
I do have a question.
Hello.
Hello.
Yes, this is Bill speaking. On one of your maps, you showed where other meteorite fragments had been found from Kuke through Mabe all the way over to further east. And you'd mentioned that those likely came from asteroids that had passed by some millions of years ago. So if we have things breaking off from asteroids and actually making it to the Earth that long ago, I'm trying to think of what the likelihood would be of actually finding them on the surface. And would it be that there were so many fragments that they may have been covered and uncovered and recovered and uncovered again by winds and moving sands and so on, or what the explanation would be for how you would find fragments that may have actually hit the Earth millions of years ago?
Yes, thank you for the question. It's actually the slides you are referring to is probably the one about the illegal collected meteorite. So I'm not sure, I don't think they are millions of years old. The point that Mr. Gabadire was making is that those meteorites, they haven't been observed in their trajectory to our planet. They have been found as shiny looking stones by scientists without a permit and by local people that collected these stones, and eventually the scientists recognized meteorite, so identify them as meteorite. You're very correct. Meteorite, exactly all the other rocks and sediments, once they fall on the surface, they are subject to being buried, to being destroyed. So that's what makes our meteorite so special. We've seen it in the sky, we saw it exploding, we found it on the ground, we locate it, and we are now studying it. Very often you find a piece of a meteorite from the moon, from the asteroid belt, but you didn't see it arriving. Maybe it was 100 years ago, maybe more. Just to contextualize the answer to your question, we rushed into the field before the rainy season arrived, because one of our concerns was that once the rain starts, all the small fragments of meteorite would be buried under the sand or washed away. So that's a very good point.
Honorable Minister, we are glad that you joined this Zoom conference. I hope you heard the whole fascinating presentation by Dr. Fulvio. Honorable Minister, would you like to say something?
There is a question that says craters, meteorite craters, monuments. Somebody earlier posted the question. Yes. Okay. Does it mean that impact craters in Botswana are also heritage sites? Yes, they are. If it is proven beyond the reasonable doubt that these are meteorite craters, then indeed they are heritage sites and they will be declared monuments, natural monuments. And as we speak, the one for Asteroid 2018 LA, you know, it is actually, we've just collected the 23 meteorites in a small section of the strain field. And surely from what we have discovered, we should be having more meteorites there in the CKGR and possibly much, much larger ones. As the law says, the Monument and Relic Act says, we are supposed to protect this site as a heritage site or to be declared a monument. And we believe from, you know, discussions, maybe the point where we discovered the first meteorite should be some kind of a campsite, you know, that can be used by tourists to go and, you know, view stars, because, you know, within the CKGR, it is actually a very open ground and that is suitable for viewing of stars and so. So indeed, the craters are also heritage sites. Thank you.
Hello.
Hi, Tembizo.
Hi, Dr. Franchi. How are you?
I'm fine, and you?
I'm good. I have a question.
Go ahead.
You formed the Astronomical Society of Botswana in Botswana, and I believe this organization should stay there for life. My question is, do you have anybody from University of Botswana or Botswana International University of Science and Technology, which is BUIST, a student doing master's or PhD in this meteorite, such that we can groom him or her as one of the astronomers or whatever specialist on meteorites? Because I believe that when Dr. Franchi leaves Botswana as the head, the society might come to an end. So my question comes, is there anybody you are grooming as the society or as the scientist who discovered the meteorites from the CKGR from Botswana, such that he or she can maintain this organization of the Astronomical Society of Botswana? Thank you.
Tembizo, thank you for, can you hear me?
Yes, Dr. Franchi, I can hear you.
Thank you for your question. So the Astronomical Society of Botswana is actually a society, maybe Jihan, you can confirm, is actually based in Gabs, and there are many amateurs as well as scientists, and I'm just a member. I don't actually sit in the board. I don't have any role there. So rest assured that it will live, and it's actually thriving. Am I correct, Jihan?
Yes, yes, Tembiso. And Doctor, the Astronomical Society has its secretariat at BUIST, but it functions from Gaborone, from Kanye, and it represents Botswana in Sarawak. So it's independent of BUIST, though the secretariat is located at BUIST. So it's functional independent of BUIST. And
But
we've invited Dr. and other lecturers from BUIST to make these presentations from the ASB.
But sorry, let me follow up. You have a good point, Tembizo. In the past few years, we've been trying to create a center for planetary space science at BUIST. We are working restlessly to have what you suggest here at BUIST or in Botswana in general. There are many problems, one of which is funds and human capacity. As you might know, there are not many planetary scientists in Botswana. We have now some astronomers at BUIST, but people with real interest in planetary science. I know myself, Siamo at UB, but is more onto the big data side. So we are trying to bring people here. So in the very near future, we will have someone trained in planetary science, Bazupi. I'm not sure if it will be on this Meteorite, but it will be definitely, it will happen very soon. We will have a master's with their project in planetary science and space science related topics.
I believe the Honorable Minister of Tertiary Education is also one of the participants at the moment. Honorable Minister, would you like to say something?
Oh, good evening, everybody.
Good evening.
Good evening.
Good evening.
Can I go ahead?
Please.
No, good evening. Thank you very much for the opportunity. I joined late. I just joined the conference just now, and the lecture I've had is really interesting. I just want to extend my invitation to you, especially the ASB, to take advantage of having somebody who's got a lot of interest in this field, being in the office of the Tertiary Education Research and Science and Technology, so that we should meet, find some time so that we should meet and see how we can work together, take advantage of me being there. It will be good to work with you. I just listened to a lot of very good contributions. People like Tembiso being worried about the continuity of everything, but the answer was satisfactory. I just want to say I really enjoyed the little part of it. I was in Parliament. I just left Parliament now. Next time, I'll definitely be the first one to log in. And if there's some recordings, if there's a possibility, I would definitely love to listen to the presentation. Thank you very much, everybody.
Thank you, Honorable Minister. We will take up your invitation. We appreciate that.
Thank you.
Any more questions?
I might have one more question if I can put it in. On one of your slides, you mentioned that only 27 out of 60-something thousand known meteorites. Do we actually know where the meteorites came from? That's quite a big ratio. So going forward now, what would you expect that ratio to maybe now become? I would guess that because of various advanced techniques and more telescopes and so on, that ratio would come down to where, yeah, we might know where more of them actually come from. How is that progressing?
Okay, thank you for your question. I'm not an astrophysicist, so I I know very little of observations of these objects. I'm a geologist, I'm hard rock geologist, so, but I will try to give you an answer. If you look at the timeline I gave, there are three known events of which we have a trajectory of several hours before the object gets into the atmosphere: 2008, 2014, 2018. So you see, before that, there was none. So our capacity of studying this object, discovering this object when they're still far away from our planet, it's improving. And at the Catalina Sky Survey, they are the one that spot the three of them. So they are specialists on that. So I'm very optimistic. I mean, if there will be other asteroids, we will see them and we will find them. And this is how science improve, improving the database, improving the data. Let me say that, even though I'm not an expert, but I can tell you that most of the studies done on asteroids and meteorites, they are comparative. So you compare with what you know. So clearly, the more you study, the more people you have on the spot, the better is our knowledge of these objects. So it's a process that feeds itself. More information, more details we get in the future. But if you have more specific questions on, this is to everyone, if you have more specific questions about this beautiful topic, I'll put my email into the chat. So if you send me the questions, I'll make sure to convey your question to the right experts in our group, and I'll find an answer for you, if that is of your interest. So I put my email now.
Thank you for this, Dr. Fulvio. Any more questions?
Thank you, Fulvio.
Any more questions?
Gian, maybe
Yes.
one more comment from me.
Yes.
Given that we are really honored to have the minister on the call, I think it just goes to show his commitment to science, both as a professional but also as a legislator, and also to say that the government of Botswana has been doing some great things. Fulvio and myself and Professor Bode, that is in the call, have been in the task team for developing the Botswana space sciences strategy. It talks to 3-4 pillars on remote sensing. It talks to planetary science, and it talks to astronomy and astrophysics, especially regarding our involvement in the SKA project. And then it talks to the supporting platforms. Like I said, we just arrived from a site visit near Kang, where Botswana will host part of the SKA project in the future. And maybe just to reiterate, these projects at the apex are about science, but underneath in the pyramid, they're all cross-cutting benefits, both in infrastructure and in developments that will come because of the scientific endeavors that Botswana is participating in. So really going forward, these are opportunities that I believe we should really transcend them to our students, both in our curricula, but also inspiring them with the fact that they can get into science. Let's also not forget that science is not something that is far-fetched. Indigenous knowledge regarding astronomy has always been there. Our grandfathers knew what meteorites were, and there are very, very few books written on indigenous astronomy. So I think there are some great potentials there in terms for Botswana regarding heritage, regarding cutting-edge science, and regarding development of infrastructure. So I think the minister being here also is very, very good tribute to his engagement in science. Thank you very much.
It certainly is. Thank you, Dr. Siamo. Any more questions?
Could I just say one or two things, Gian? Sure. Hi, Fulvio. So I'm speaking to you from near Liverpool in the United Kingdom. So it just shows how tremendous this facility is. And I'm just so sorry that I can't be with you in Botswana. But I completely agree with everything that's just been said by Chamo. And Botswana has so many advantages for planetary science and astronomy going forward. You have tremendously clear skies. You have very, very dark skies because you have a very low population density. It's an excellent place not only to look at the sky in the way that most of us are familiar with, which is through optical telescopes. It's also a fantastic place to look at the sky with radio telescopes, and that's what we're talking about with the SKA and the AVN just being mentioned. Geographical position is superb. It's a very stable country. It's great as a partner. And it has something that Fulvio has talked about before to the Society, as planetary analog sites, sites that are tremendous analogs of the surfaces of other planets in our solar system and places where we might search for life in extreme environments. Anyway, you know, I think it's been a superb talk, thanks to you and your colleague. And this is a society that is going from strength to strength with people like Gian and all the colleagues on the committee who work so tirelessly for it. And it's superb tonight to have seen 80 participants at one point taking part in this. So from a slightly a sunny Liverpool, I'll wish you all the best and say see you in Botswana, I hope, as soon as possible. Thank you.
Thank you, Professor Bodhi.
Good to hear from
So
you.
we have participants here from the UK, we have participants from South Africa, we also have a participant from Sri Lanka. Dan, would you like to say something? Okay, no comments there.
Hello, here is Thomas.
Hello.
Hey, Thomas.
Yes, I am in the car just now, but not driving as a passenger. Thank you, nice presentation, and it was nice to remember all the moments from how we get into touch about planning the expedition and then finally actually being in the field. And I am happy that the things are proceeding, and I am looking forward to see the meteorite eventually on display. So I encourage you that the museum exhibition will be finalized.
You're breaking.
While he's breaking,
Now in Germany, and they will be displayed all together.
You're
While-
breaking, Thomas.
this is Thomas Coates, is one of the person that initiated the research, so everyone knows. Now, unfortunately, he's in the car, but he was with me in the CKGR. Thomas, we cannot hear you because you're breaking.
You were breaking, Thomas.
Or not. Do you hear me now?
No, it's not clear.
I will stop somewhere. Yeah.
Okay, because it's oh. Do you hear me?
No, it's not clear yet.
Write it in the chat so we can read it.
Yes.
Someone
Any
is
other
writing,
questions?
someone is writing that we have inspired many students in the country. I hope that these students will come to BUIST and they will look for us and keep us accountable for our promises and come and say, hey, you said that there will be a research in planetary science. Now I want to do that. I'll be very glad. To have some students committed to that, because you know there is something beside mining, which is very important, of course, and it's important that our students in the university, they understand that you can actually contribute a lot to the economy of your country if you differentiate. I'm a geologist, but you will never see me dealing with mining stuff. So I'll be very glad is Anandi if it's true what you say, would send them here.
Just to let you know, about 8 to 9 students of mine are hearing you as I speak. So that's the level of interest that ASB has brought amongst my students. And thanks to all the committee members, Mike, Gihan, and everyone else. And your presentation was extremely interesting. Thank you so much. You took us through a whole journey from before landing to after and finding. So it's very interesting.
Thank you. Thank you.
Andy, would one of the students from Westwood have anything to say? Would one of the students from Westwood
good evening. Hello, everybody. I just caught a piece of Thomas Kohut's observation. I know he was saying something about ensuring that the meteorites actually become available for viewing in the museum. And I'd like to share with you that the Botswana Geoscience Institute is working on that. And the meteorites were a huge opportunity for us to be able to share the collections that we have in Botswana. So indeed, we're looking at, in a not so long period, ensuring that these meteorites actually become accessible for viewing by the public.
Thank you. Any more questions?
Good day, Jihan.
Your students have something to say?
I've just WhatsApped them and I've asked them.
Okay.
I'm not sure.
Would really like to hear one of them.
Yeah, Jihan, this is Komotso.
Hello, Komotso.
Yeah, I'm speaking here from BUIST. Mine is just a comment following in from what Dr. Tiamo was saying about the trip that we undertook to Kalani. I'm the project manager for the AVN Botswana radio telescope. So I can say it's a more related project to what Dr. Franchi has been presenting about. And I can say it's exciting times for Botswana. We are hoping that with the many programs that are being undertaken here at BUIST, next time maybe Franchi would not be saying they observed the meteorite through somebody's telescope. They will be observing it through a Botswana telescope. So I think just my comment is we are hitting the ground. We are running with the radio telescope. Work is being done here too. He has mentioned Lokalani as a possible site. Yeah, we are working towards many other sites maybe to have this AV and SKA ongoing. Thank you very much.
Thank you. One more question before we close.
Hello, Tim.
Hello.
Yes, it's Rachara here. And I just wanted to say thank you to the team for inviting us. I'm the president of the Botswana Geoscience Association, which is the BGA, and we would be really interested in attending presentations like this one. And we will also be probably interested in making sure that our members also probably come and join the expeditions when they happen. I can see there's a lot of activity, and we have a lot of young geoscientists that are with us that really would be excited to join this. So I was very, very pleased to be invited, or the BGA be invited to this. Hopefully it was Prof. Proya who put us on the list there. Thanks also for him, because he's our member. And also I'm really excited because I can see that the minister is here with us and joining hands in the geoscience, which is a very good thing. And
I'm looking forward to working with the association, SBG and the association, and also BGI, because this is where we can start as a country and as geoscientists to be together and work together on things like this. I'm really thankful for that.
Thank you very much, Rashiri. So the Astronomical Society is very thankful for all the participants. There was 80, there's 56 at the moment. Dr. Fulvio, we really need to thank you very much for this fascinating presentation. And I know you just told us a fraction of all your knowledge and the information that you have within you. I've been privileged to have face-to-face discussions with you, and I know you are an extremely fascinating person. The travels that you have, the research that you've done, and we really hope, the Astronomical Society really hopes that someday soon you'll make another presentation with more information. And thank you very much, Dr. Fulvio and Mr. Khabadirbe, and everyone else for participating. The Astronomical Society of Botswana thanks everyone of you. Good night.
Good night. Thank you for inviting me. Bye.
Thank you. Good to see you, Fulvio. Bye-bye.
Thank you. Bye.
Good to see you, Michael. Bye. Bye.
Yeah, good to see you.
Bye. Bye.